Hello everyone. In today's lecture, we shall be completing our some of the few basics that we have in continuation to all the basics that we have done so far. We'll be completing the rest of the topics. Today we'll be taking current and voltage division principle and some relevant questions. Again, I'm repeating, these are just your basics, right? And you must have been seeing these questions since whenever you started doing network theory. So these are very basics, but I still want you to attend the lecture because these are these are places where you're bound to make mistakes. Okay, so just go through the lecture, hear it, attend it once, and we'll from there we'll take, like, once we're done with basics, we can go to AC networks and things more difficult from here on. Okay, so first and foremost, what is voltage division principle? So first I need you to understand what is a series connection and what is a parallel connection. So in series connection, the current through the elements remains the same. Okay. In series connection, the current through the elements remains the same. For example, here in this figure, Z1 and Z2 are in series because the same current I flows through both of them. Now, the voltage in these impedances divides in the same ratio as the impedances. For example, the voltage across Z1, the voltage across Z1 is equal to V1. It is Z1 upon sum of impedances times the total voltage applied to the network, right? So this is a basic uh, thing that you've done so far. It is a series connection. That is how you identify what is a series connection. We have done star delta in the last lecture. We know what is a star configuration is. What we know what is a delta configuration is. We've also done series and parallel configurations, but we have not done them by name. Today we'll be doing what is voltage division principle and current division principle in series and parallel networks. Okay. So similarly, in case I have to calculate the potential across impedance Z2, that would be equal to V2. It is Z2 times sum of impedance into the total voltage applied to the network. Okay, so the voltage divides in the same ratio as the impedances. See, here the potential V1 is in the same ratio as Z1, right? Right? Now tell me, what if, what if Z1 is equals to Z2 is equals to Z3 is equals to Zn, and let that impedance be uh, let that impedance be Zn. Then tell me the potential across the nth potential would be what? The nth potential would be what? It should be V upon N. Do I need to explain this? See, it's very easy. How? If 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 you have n number of elements here in this network, and the potential we know as a rule is based on what? Is based on uh, there will be one Z here, and now there will be sum of impedances here. What are the total number of impedances in our hypothetical question that I was discussing? There are n impedances. So can I write it to be Z upon n times Z? So it will be what? 1 by n times V, right? Can I write that? Right? Okay. Now tell me, would anything change? Would anything change if we are talking about capacitors? If the impedance is capacitive in nature, would anything in your relation change? See, the relation shall remain unchanged because what? We're talking about impedances, right? If you're talking about the impedances, the relation shall stay unchanged even when the network is capacitive, right? But what if? What if you're asked the relation of voltage division in terms of capacitances? Then, because we know in capacitive networks the impedance is equals to 1 upon what? J omega C. It is the inverse relation, right? So, if you're asked voltage division in terms of capacitors or in terms of capacitances, we shall write V1 is equals to what? V1 is equals to C2 upon C1 plus C2, right? Please be very clear. If you're asked in terms of capacitances, because impedance in itself is what? It has an inverse relation with capacitance. So your formula would transform in such a way. So in case you have to find the voltage division in terms of capacitances, it is inverse to the normal voltage division in terms of impedances, right? Okay, I hope it's clear till now. Okay, now tell me in terms of current division. Now tell me, what does a parallel network show? A parallel network shows that there is the same potential applied across the two elements. When there is the same voltage across the two elements, yesterday what did we talk about? We did talk about equipotential nodes. Did we not talk about it? Yesterday, when we were doing questions, did we not talk about equipotential nodes? So if you look closely, this node and this node is what? An equipotential node. Similarly, this node and this node is what? Equipotential node, right? So, so a parallel network is where the same potential is applied across the elements. In this case, there is potential V applied across both Z1 and Z2, right? Now, in parallel networks, in parallel network, the current I divides in inverse ratio of the resistances. For example, current in this branch I1 is equal to what? Is equal to Z2 is equal to Z2 upon Z1 plus Z2 times the total current I1. The current in this branch, in branch Z1 is equal to what? Is equal to Z2 upon Z1 plus Z2 times the total current I, right? Similarly, similarly, can I write, for I2? I2 is equals to what? I times Z1 upon Z1 plus Z2, right? Sum of impedances, right? Okay. If you're given with equal impedances, what would your relation be? Can I write current in the mth branch is equals to I times M? If remember, if the impedances are equal, only then, right? Okay. So far are you clear with whatever I've discussed? Okay, moving on. This is the question that you're asked, and you have to determine the current in this branch I. In this branch I, you are provided with the current in this branch. Okay, you're provided with the current in this branch. You have to calculate the current in this branch. Okay, so tell me, how are you going to approach such a question? If you look closely, you will realize between B and C, R and 2R are what? Are in parallel, right? So the current in this branch, if it is given to you, let this current be, let us say, let's name it as current. I'm calling it current in branch BC. BC is here also, so I cannot give that nomenclature. Let me name it as I dash. Okay, right? So, so now that you know the current in this branch is given to you as 1 ampere, right? So if you're given in the previous slide, we know if the you're given with what in this case? You're given with I1 in this case, right? You're given with I1, you have Z2, you have Z1, you have Z2 again. You do not have the total current I. And what is the total current I in our case? It is I dash, right? Right? So how would I write it? I would write it as 1 equals to I dash times C. It is inverse ratio. It should be what? Inverse ratio, because in current division, what did we learn? We learned that the current divides in the inverse ratio. So shouldn't I write R, the resistance of the opposite branch, upon sum of resistances? Right? Right? So this makes 1 equals to I dash into 1 by 3, which implies I dash is equals to what? 3 amperes. Am I clear so far? Right? Right? It makes sense. As of now, does it make sense? Now, if you look closely again, please stay with me in this question, okay? If I look closely, this branch, there's a resistor between B and C, which is 2R. Similarly, there's a group of resistance of R and 2R. There's a branch here again. So this branch and this branch are also eventually in parallel. If you see, between B and C there is a resistor, and between B and C again there is a resistor. And what did we learn in how do we see parallel networks? If two elements have the same starting and ending points, they are in parallel, right? So these two are what? In parallel. If there is a current of 3 amperes flowing in this branch, can I calculate the current here? Tell me, can I calculate the current here? Let me name it as I double dash. Can we do that? Look, this time you're given with what? You're given with current is equals to what? 3 amperes, right? Is equal to what? The total current in this case would be what? I double dash. Look here. This is the current. It is dividing into two branches. So I double dash. We're calculating I double dash, right? What would be the resistor this time? See, this is I dash, which is flowing in these two branches, but the current divides in the opposite relation. So what will I write? The resistance. I'll write 2R in the numerator upon sum of resistances. This would be 2R plus what is the resistance in this branch? Can I write it to be R parallel to 2R? Right? What is R parallel to 2R? What is R equivalent? It should be R into 2R upon sum of resistances. This should be R plus 2R. This is something that you should, do very quickly. 2R square upon 3R, this would be 2 by 3R, right? So can I replace this by 2 by 3R? Right? Right? Can I write 3 equals to, this implies 3 equals to I double dash times 2R upon 2R plus 2 by 3R, right? Right? Now solve this. This would become 3 2s are 6, 6 plus 2 is 8R in the denominator and 3 will go up, so it will be 6R. So I'll rewrite it as again 6R upon 8R, right? Can you calculate, did you also find I double dash to be 4 amperes? As of now, have you reached till this step? Have you reached I double dash is equals to 4 amperes? Right? Right? Now, what are we asked? We are asked in this the current in this branch I. We have till now so far what do we have? We have the current in this branch I double dash, right? We have current in this branch. What are we supposed to calculate? We are supposed to calculate the current in this branch. It is just a very tedious question, but because we have to learn, we'll learn it. Okay? Okay. Remember, because I cannot take this calculation to the next slide, I won't be I won't be calculating this at each step. Remember, the parallel combination of R and 2R will give you a resultant equivalent resistance of 2 by 3 R. Okay? I won't be doing it again. Let's take it also so that you don't get confused. Okay. So far, what have we done so far? We've calculated current in this branch so far. Okay? Okay? Now you know the current in this branch, and you do not know the current in this branch, right? But you do know the current in this branch. If you do know the current in this branch, can you calculate the total current through the supply? See, we have calculated I double dash to be what? We have calculated I double dash to be 4 amperes. So till here we have reached. Now, can I calculate the current through the supply? Let me name it I triple dash. It will be by the same principle, right? So tell me, what will you write for I triple dash? What is I triple dash? Can I write? Tell me, can I write 4 is equal to I triple dash times, now this is where it gets tricky. See, this is what? What is the resistance in this? We are given with current in this branch. When you are given with current in this branch, what will be the numerator? Numerator will be this branch. So what will this be? What did I calculate this to be? This is 2 by 3 times R. Can I safely write it to be 2 by 3 times R? Right? Upon, tell me what is the net combination resistance in this branch? Can I write it to be, look closely. See, 2 by 3 will repeat because it is what? Z1 for you plus. Now look here. Can I write it to be 3R plus, look closely, 2R parallel to 2R parallel to 2 by 3R. Is it right? Till now, do you follow? I am solving this part for you here. Okay. So tell me what is 2R parallel to 2 by 3. Can I write it to be 2 into 2 by 3 upon 2 plus 2 by 3 times R. This would be what? R equivalent. Can I write it? Right? So if you solve it, it would become 4 by 3 upon 3 2s are 6 plus 2 is 8 by 3. Right? Right? So this becomes what? This becomes 1 by 2. 1 by 2 I'll replace here. Right? Plus 3. 1 by 2 plus 3 is 1 by 2 plus 3 is 3 1 by 2. That would be what? 7 1 by 2. 7 by 2, sorry. This would be what? 7 by 2. So I will replace this entire thing by what? 7 by 2. Right? Now 7 by 2 plus 2 by 3. What does that make? Tell me, what does 7 by 2 plus 2 by 3 make? I am just solving this denominator here in the rough column for you. This would be what? 6, 2, 3 sevens are 21, right? Plus 2, 2 twos are 4. Does that become 25 by 6? So your entire denominator reduces to what? 4 is equals to I triple dash times 2 by 3 times R upon, what will I write here? 25 by 6, right? Times R. Okay, right? What would this reduce to? This would become, I am writing it again, 4 is equals to what? I triple dash times 4 by 25, or I triple dash comes out to be what? 25 amperes. Right? Am I clear so far? See, now if 25 amperes flows from here, 4 amperes flows in this direction, what will be the current here? 4 we have calculated in the previous slide. Look, this is 4 that we have calculated. This is the current in this branch is 4 amperes. And now we have calculated current here to be what? 25 amperes. What will be the current here? Simple. 25 minus 4 would be what? 21 amperes. Right? Now can you calculate I? Now it's very easy. If 21 amperes is flowing here and you have to calculate the current in this branch, what will you write? Opposite branch upon sum of branches, that would be R plus 2R, that would be 3R, right? Into what? Into 21. This would make your answer to be what? 14 amperes. So this was your question. All you needed to do was simply apply current division throughout. Right? It's a very simple question, and I think you have done, so far you've done such questions in your, you generally do such questions, so there's nothing new in this question, okay? But you need to just, for the sake of completion, I'm completing these questions, okay? Okay, look at this question and try and solve it step by step. You are required, in this question, you are required to find out the current I, find out the potential across 2 ampere source and the current through the resistance of 1 ohm. Now tell me, how will you approach the question? Okay, so if I redraw this circuit, instead of joining it like this, if I join it like this, would it be any different? I am just redrawing this circuit like this. It is the same thing. There's a resistance between these 2 points. Yes, there is. So nothing changes, right? Now tell me. Now tell me. Can you calculate the current in this 10 ohm branch? You have the resistance, you have the potential across it. In parallel, the potential remains same. Can you find out the current in 10 ohm branch? What will be the current in 10 ohm branch? Tell me. I across 10 ohm. What will it be? What is the potential across 10 ohm branch? It is 10 volts. What is the resistance across it? It is 10 ohms. What will be the current? It will be 1 ampere. Right? Now, your very easy question that was asked to you. What is the current in resistor R is equals to current in 1 ohm resistor? What is that? What is the potential across it? It is 10. What is the resistance given to you? It is 1. What is the current here? 10 amperes. So far, you did not encounter any problem, did you? No. Now, look closely at this node. Tell me all the currents approaching this point. All the currents approaching this point. By the concept of KCL. By the concept of KCL. Every outgoing current, the sum of every outgoing current should be what? 0. Now look at this node A. Let us mark this current. Let us mark this current as I. So the current which is asked by from you is the current leaving this source, but it is what? Incoming to the node. What will I write? If I is incoming to the node, can I say minus I would be outgoing? Right? Similarly, 2 is incoming to the node. Can I write minus 2 would be what? Outgoing current from this node, right? Now, did I calculate the current in this branch? What was that? It was 1 ampere, right? And what was this IR? It was 10 amperes is equal to what? 0. Sum of all outgoing currents is what? 0. Did I calculate I? What does I come out to be? 10 minus 2 is 8 plus 1 is 9, and if I send it here it will be minus 9, minus minus would cancel, so I comes out to be 9 amperes. So we have so far we have calculated I and IR. Two of our questions have been solved so far, right? Now what is asked to you again? Tell me what is asked to you. You're asked what is the voltage across the 5 ohm, what is the voltage across this current, right? Right? Now tell me, it's very easy. There is a 10 volt in totality here, right? Right? If 2 amperes is flowing in this direction, this would be what? Plus. This would be what? Minus. Right? Apply KVL in this loop. Apply KVL in this loop. Okay. Now see. We have to calculate the potential V. Now I am traversing my loop from negative to positive. So I will write just V. Right? Now in the direction of current, what do we experience? We experience a drop. So it will be minus 2 times 5. Right? Now travel here. This would be again from plus to minus. So this is again minus 10 equals to 0. Can I write V is equals to 20 volts? So this was your question for today. Okay. So far we have done almost everything in our basics. All we are left with is question based on balanced bridges. That is the only, in my understanding, that is the only question we have left uh, in terms of basics. Rest everything we have done, we have completed so far. Okay. So tomorrow would be the last, I believe, would be last lecture on basics, and from Monday onwards we'll take a few more. We'll take a complete extended lecture on all the questions. Yes, miscellaneous questions. So once you see a variety of questions, you will understand what approach you need to apply for different questions. Okay. So tomorrow will be the last class on balance on basics. That would be somewhere around bridges. Okay. So attend the class tomorrow. Tomorrow will be our last lecture on basics. Okay. See you tomorrow. Bye bye.